that if the IV increases, the DV also increases, isn't it? Yes or not? It makes sense, right? But I said decrease, that's not all of you keep quiet. Okay? So here it means that every unit increased by the IV, the DV is likely to increase at the same time. Understand? Can. So you need to do the same thing for all the IVs. So in your case, you have 2 IV, 1 DV. You need to do twice. Okay? This was yesterday's work and last week's work. All of y'all clear?
Yes.
Clear? Okay, so now we will look into the next new step. Okay, you have Pearson correlation test. This one you want to see whether there is a correlation between the IV and the DV. Okay, so in order to do this, basically it is done to recognize, okay, the level of correlation between the variables. The higher the correlation, the better it is. Okay, so usually this table, they follow this table over here. Now this is totally opposite than the p-value over here. Here the p-value has to be more than 0.05, right? Okay, but here the p-value has to be lesser than 0.05. Okay, alright, and then you follow this table over here. That's all. Alright, okay, so now you look at your table that you have. Okay, go to analyze. Okay, then go to correlate. Then go to bivariate. Okay. So you get these tables, right? Yes or not?
Yes.
Okay, you see the word variables. So variables means including your IV and your DV. Is she okay? Kiana? Right. Okay. So you look at all your variables. Total POU, total PU, total TR, total SI, total CI. Okay, all of y'all done this? Can? Right, just after you put in all the variables, just press OK. So when you press OK, you will get this table. All of y'all got this table?
Yeah.
Okay. Since there are 5 over here, because they have 1 DV, 4 independent variable. Okay, but now, right, let me see if I can. Okay, never mind. Alright, okay. So if you can see over here, okay, if total POU, PU, TR, SI, CI, always start with the DV, right? Okay, where the DV column is. So if you see the DV column over here, then you just take this part over here. Can you see this part over here? Okay, I don't know how to you know, put a pen here and marker or whatever. Okay, but never mind. Okay, this part over here. Okay, can you see total CI with total POU is 592, right? Total, okay, then total PU with total CI is 0.665, right? Total TR with total CI is 347. Total SI with CI is 363. Obviously, total CI with CI, the correlation behind will be 1. Okay? Alright, because it's the same. Alright, can
So
okay.
we only need to attach the total CI
No,
value.
you attach the whole
The
table,
whole thing, okay.
but I'm telling you how to interpret. But if you don't want to see this way, you don't like horizontal, you like vertical, then you do it this way. It's the same reading. Can y'all see? You see this side? 592, 665, 347, 362, and then 1. See total POU with total CI, PU with total CI, TR with total CI, SI with CI, and CI with CI. Saw that? So you just need to see the relationship between IV and the DV. Okay? So you need to look into the correlation. Which is the high correlation? So when you look at it, which is the highest correlation here?
The first one.
0.592.
Second one.
0.665.
Was it lower? Lower is better.
Oh, it's better.
Okay, look back.
Oh,
at
the one that's 0.02? No.
Okay, look back.
So CI lah, the number 1.
So which, look at this, okay?
Yeah.
So the higher it is, the higher the number is, the higher the correlation, right? Okay. So which one has the highest correlation?
CCI and PU.
Okay, CI you cannot look into because you're not looking at the relationship between CI with CI.
PU lah then.
Ah, it's PU, right?
Yeah.
All of you all understood why is it PU? Why? Because it's 0.665, the highest, right? So 0.665 falls under the category of high correlation. So the second highest would be PU. Good. Alright. So this one, oh, don't let me so sleepy. Okay, I also want to sleep already then. 0.4 to 0.6. Okay? Can? Alright, moderated correlation. So you need to say it's moderated correlation. So this one, the third one is 0.362. This falls under SI. So 362 is here. It falls under low correlation. Okay, and similarly, the last one, TR, also falls in the same one. Yes.
For the PU, is it moderate or high?
Which one? For PU, 665. You look at the table. 0.665, right? High correlation.
So if it's 0.61, also high.
Yeah. Okay, it's under high. Yeah.
So after we attach the table, do we write descriptions for each variable?
Yes.
Low correlation, high correlation.
Yeah.
Okay.
You need to write a description for that. Okay, so sometimes people can actually look at it, and obviously all is okay. People can look at it and they can see whether the decision for p-value, when they look at the p-value over here, they can sort of guess, okay, right, which will be significant or which one will not be significant. Okay, so if the p-value is lesser than 0.05, okay, it's usually the test is significant. If the p-value is more than 0.05, then the test is not significant. So there's a possibility of POU and also PU to be accepted. Can you see the significant two-tail? Saw here or not?
So if one of the variables is like insignificant, what do we do?
Doesn't matter.
Can just write it out. It's insignificant.
That's your research, yes.
So it's not our fault lah.
Yeah, it's like I cook and I say, you know what, my dish is so nice, you know guys, today I'm bringing biryani for y'all, eat it. Then I ask y'all for ratings and all of y'all give me bad ratings. I have to accept it, right? You understand or not? I have to accept it. I can go ahead saying that my biryani is the best. But if all of y'all say it's bad, I have to accept it and say, okay, as much as I think my biryani is nice, however, my students feel it is not nice. I have to accept it. Get the point? Okay, alright? Okay, so looking at the significant two-tail, but this one significant two-tail no need to write. This one usually I ask the master students to write or for FYP lah, but for this one no need. Okay, so sometimes you look at the significant two-tail. See, can you see they already give you the error, the symbol over here. Okay, this is less than 0.05, which means that the test is significant. Okay, alright. So there's a positive relationship between the IV and the DV. Possibility. So the stronger the IV, the stronger the impact on the DV. Okay, this is the possibility. You already know these two. Tak boleh pakai. You cannot use it at all. Okay, it's definitely going to be rejected. But we haven't confirmed yet. So we will look into the next test. Okay, so for this one, okay, let's see. Let me show you any sample first. Okay, can you see the Pearson correlation over here? Okay, see, this is a sample of students' work. The table below illustrates how to understand the size of correlation. So size of the correlation table you can find anywhere you can get the citation. Okay, so the student found the citation. You want to put this, okay. There's so many else. Okay, others as well. So this is the table.
So do we also attach the SPSS table?
Yes.
And this table we make one.
Yes.
Okay.
Okay, then after that you write the scale of correlation. Okay, so Pearson correlation. Okay, this one the student explain lah. 0.2 means what, 0.4 is what, 0.6 is what, moderate. Okay, alright, so Pearson R 0.8 indicates strongly related. So he put in the table. Okay, so he's looking into this. So I don't know what is PE and SQ. I haven't read the paper. I don't remember. Okay. So which is higher, SQ or PE?
PE. SQ.
SQ 0.669, right? This is above 0.6. It comes under high correlation. Okay, right? And then this will be maybe moderate correlation. Okay, right? Okay, so the student have to explain this.
So how come their sync is like 0.00?
Sorry? They got 0. Okay, this is the old one, old SPSS. It will not show you above or lesser or whatever. Okay? Alright, so you all are very lucky. The new one will show you all this. Okay? So yes, so the student wrote, okay, this one a lot lah, the student wrote. No need to write all this. Okay? This one all no need Okay, start from here. If the significant value is greater than 0.05, we want you to reject the hypothesis link. Okay, that one also I think no need. Alright. The Pearson correlation coefficient between physical environment and customer satisfaction is 0.596, indicating a moderated correlation. The Pearson correlation between service quality and customer satisfaction is 0.669. Indicating that these variables are highly correlated. These data imply that the physical environment has a higher influence on customer satisfaction than the quality service. That's all.
So the sentences are pretty much similar.
Similar to?
Like the sentences is general.
Yeah, you just need to say whether it's highly correlated or low correlated or medium correlated.
So we just follow the structure.
Yeah, you just need to mention how you want to do it. It's up to you. Okay, I'll show you another student's work. Okay, like this. This example, okay, significant. Okay, here. If alright, don't do this. This one before. Okay, with a Pearson correlation score of 0.642. Okay, reveals there is a strong link between. Okay, there's a strong link between salary and employee motivation. The Pearson Association, on the other hand, demonstrates there's only a moderated correlation between employee motivational and non-financial value of 0.436. So therefore, this suggests that the salary has a greater impact on employee motivation than non-financial rewards. How you write it, it doesn't matter. But as long you say whether it's highly moderated, or either it is highly correlated